Test. Hold up. I gotta check some things. What's going on with my audio? Or I feel like we're not getting any sound from my actual machine, but like that's something looks wrong. Hold on, I gotta look at. I gotta listen to this. I feel like we're not getting any. Never mind. Apparently we are. I had to check. The audio levels in OBS are like bugging out. Like it's not showing. Okay, no, it's working now. I guess that's just something weird about that song in particular. That's weird. I guess it's also because it's like kind of quiet. All right, never mind. Forget it. Anyway, yeah, we're back. We're continuing the natural number game. My goal today is basically just to try to complete this. I mean, I think we're getting close to the end. We have like 1, 2, 3, 4, 5 worlds left. So yeah, we've got like a couple weeks left to do this because after this week there should be one more weekend of no Star Force, and then we're gonna go back to Star Force. We're gonna be doing Star Force 1 post game in a couple weeks when Juka returns. So yeah, we have basically 2 streams budgeted to finish this game. So if I can't finish it today, then there will probably be one more stream of this just to wrap it up. But yeah, hopefully it doesn't take too long. Hopefully we don't have to worry about that. Okay, add left cancel ABN is the theorem that n plus a equals n plus b implies a equals b. You can prove it by induction on induction on n, or you can deduce it from add right cancel. All right. And we have add right cancel here. We proved this in the previous level, apparently. I do not remember the syntax of basically anything. Oh, what's this? We got like a little cross. Huh. Or is that isn't that dagger? They usually call that dagger, right? That's usually what that symbol means. It's not actually a cross, even though it kind of looks like a cross. So yeah, this one is a function. So it takes a plus n equals b plus n and gives a equals b. Okay, so I think what we need to do then is just like rewrite these to swap them around and then do an add right cancel. So there should be something that says that the add is commutative, right? A plus b equals b plus a. Okay, yeah, there we go. So if I want to do this, I should, I think, it's RW, right? In Idris, it's just rewrite the full word. Here it's RW. We're gonna take add com, and I guess, right, we need to use this syntax. I think there's like a list syntax, probably. Ooh. Is it in or is it like with? I don't remember. And it should be applied to our goal. Okay, hold on. What is our goal? Uh-oh. I forgot basic syntax. I am in trouble. Hello, fellow leaning towers of Pisa. Yo, what's up? I forgot the syntax. I don't remember how to rewrite. I know I need to do an add com. Is it in something? I don't know. Help, elfers. There was. It's like this, right? Isn't it? Or did this already work? Is that all I have to do? I swear there's like another word afterwards. And then I should be able to like apply add let or write cancel. I don't remember. I don't remember. It's been too long. It's been 1 week. No, it was like is it apply? Is it apply with? Where's okay? Hold on. There's stuff. There's stuff I can look at. Apply. How does apply work again? Apply T at H. Right. Okay. So apply this at H. So that'll change H to a proof of Q. I did? Oh, I did. I guess I have to target them. How does this work again? Okay, so now it's A plus N and B plus N. Yeah. Wait, is that work? Okay, that works. Wait, so RW doesn't take an argument. I thought there was like an extra bit after the RW. I swear. Okay, that's okay. I guess that just works. I don't know. Let me look. RW is here. Oh no, it was just RW with the brackets. There is no other. Oh no, there was an RW at, but that's if you have a hypothesis. Okay. I see. Right. But I didn't have any hypotheses here. I guess I could have like done an intro on this, but I didn't. How about this for a proof? Repeat RW add column N. Oh, you can just do that? And then they did an exact add write cancel AVN. Dude, my apply add write cancel is like way cooler than your exact add write cancel AVN. You can do at underscore if you want to rewrite at a hypothesis. It's optional. Ah, interesting. Add left eq self xy is the theorem that x plus y equals y implies x equals 0. Okay, go away. We don't need you right now. So we got add left cancel added to our box. Yeah, you can do that because YouTube chat. Why is there a stupid? What is wrong with YouTube chat? I'm looking at YouTube chat on my phone, and there's like this gigantic like heart reaction button blocking part of chat. What the hell is wrong with YouTube? Why would they do this? This is the worst UX ever. Alright, so x plus y equals y implies x equals 0. Ooh. And there's no more instructions now. So they're not even gonna tell me what to do here. I see. But didn't we just do... Well, this is an add left eq self. So... If I rewrite you as y plus 0, does that work? Because you're just a y. Is there a way I can do that? Add 0. Yeah, we have an add 0. So if I rewrite this y in particular... Oh, because currying. I see. Yeah, you two block the word currying. Lovely. Okay, so if I rewrite add 0 y, what's going to happen, though? Is that not going to cause issues? Also, why are you complaining? Oh, I need to do the reverse, don't I? Okay. See, I don't really want that, though. I need to specialize on this y right here. And there's a way to do that. Okay, so I need to do an nth rewrite. 2. 1? No, it's 2. Okay, and then I go over here, and then it updates. Okay, yeah, that makes sense. And now I can do, where is it? Now I can do an add left cancel. I mean, how would you prove this non-formally? I don't know. I haven't thought that far ahead. I mean, I mean, if why uh probably with algebra, something like that. I mean, it kind of is easy to see that, like, if you want y to equal to y, then x would have to be 0. Because it has to be like y plus 0 equals y. I don't know. Anyway, I've made it this far. So I think we just need to do... Is it add... It is add left cancel, right? Oh, I might need to swap my x and y around. Okay, so yeah, I might need to do a rewrite add com. Okay, yes. And then we add... I guess we can just apply, right? Apply add left cancel. There we go. The y's are on the wrong side for add left cancel. I mean, this works, right? it let me get away with it. If I just make it look like this, then why not? Then I can just apply that. I don't know. Works for me. It looks good to me. Did you use induction on y? No. I didn't. Here's a 2-line proof of add left eq self, which uses add right cancel. Well, use add right cancel. Ah. If you want to inspect it, you can go into editor mode. Yeah. So they did an N3 right as well, but instead of being stupid, they just did an exact add right cancel x0y. Interesting. They seem to really like using exact. I'm just more like an apply kind of guy. I fixed it. Chat latency. Sorry. Add right eq self xy is the theorem that x plus y equals x, y equals 0. 2 ways to do it spring to mind. I'll mention them once you've solved it. Okay, so this is the same thing again, sort of. I mean, it kind of looks exactly the same as the one that we just did. It's just that the x and the y are different. So if I swap u around, so it's like y plus x equals x, then I could get this, I think. So I'm going to do a rewrite, add column, and then we're going to do, they're just going to apply add left eq self, right? Yeah, easy, easy. Here's a proof using add left eq self. Okay. So they intro h exact h. They also didn't apply. That's interesting. Oh, because they're doing apply at. Here's an even shorter one using the same idea. Okay, then they use exact instead. Alternatively, you can just prove it by induction on x. Okay, cool. Multiple solutions. Got it. I'm not going to stare at that too long. Yeah, the next one, okay, so they just spammed me with a whole bunch of stuff. Cases. Oh, okay. The next result we'll need in less than or equal to world is that if a plus b equals 0, then a equals 0 and b equals 0. Let's prove one of these facts in this level and the other in the next. All right. So new tactic cases shows up. The cases tactic will split an object or hypothesis up into the possible ways that it could have been created. For example, sometimes you want to deal with the two cases, b equals 0 and b equals suck d separately, but don't need the inductive hypothesis hd that comes with induction b with dhd. In this situation, you can use cases b with d instead. Huh. Okay. Weird. But it's kind of like pattern matching, so it's like a case split. There are 2 ways to make a number. It's either 0 or a successor, so you will end up with 2 goals. One with b equals 0, and one with b equals suck d. Another example, if you have hypothesis H false, then you are done, because a false statement implies any statement. Here, cases H will close the goal because there are no ways to make a proof of false, right? You can't create an object of an empty type. So you'll end up with no goals, meaning you have proved everything. Huh. Right. I guess, yeah. Here we want to deal with cases b equals 0 and b does not equal 0 separately. So start with cases b with d. Oh boy. Now things get more tricky, because now we have like way more tools in our tool belt. We have like way more things that we can try. They're introducing us to the brown keys. There's so much more stuff that we can do. So how do I start? Sometimes you want to deal with 2 cases, b equals 0 and b equals suck d separately. It kind of makes it sound like I want to do that immediately. Yeah, we just got a new tactic. This was the last thing that we just proved. Add right equals 0. So cases? Here we want to deal with cases b equals 0 and b is not equal 0 separately. So start with cases b with d. Okay. When are we getting salvages? All right. So now we have two goal. We have a plus 0 equals 0, a equals 0, and then we have a plus suck d equals 0 implies a equals 0. So now we use the power of add right equals self, I think. No. This one looks similar to one that we were looking at before. Was it add left equals self? It was add left. Okay, so add left would look like this. So that should work here. Wait, I don't rewrite. I apply add left eq self. Yeah, okay. Then for this guy, we give a plus suck d equals 0 implies a equals 0. Hmm. Wait, isn't that looks familiar? This like a plus suck whatever. Isn't that is that add suck? Yeah, add suck. It looks like this. Sort of. So what would that do? That would give me suck 0? Okay, hold on. Let's try that. Add suck. No. That gives me this. Suck a plus d equals 0. Right, yeah. No, that makes more sense. But it's not helpful. Something tells me I actually don't want to do this, but you see it. You say having solved all the puzzles. Well, I do not, sadly. What do I do from here if I can do anything? I don't think this makes sense. I don't feel like I've done something good. Because like the structure of this does not seem helpful. So okay, maybe we go back. We go back. So this is what we have, and this is what they wanted us to do. So I feel like I'm on the right track up to this point. So we have a plus some non-zero number equals 0. Therefore, a equals 0. And that makes sense. Or wait. No, it doesn't. Because how? No, this can never be 0. Yeah, because if this is non-zero, and we are only talking about natural numbers, there's no integers, there's no negatives, then we can go. Yeah, then 0 plus suck d will always be a successor of something. So if that can't be 0. So this entire thing is just false. Like if the hypothesis is false, I need to come up with a way to make it look false. How do I do that though? Huh? Yeah, I feel like maybe I do that rewrite then, because like successor of something can never equal to 0. I'm just wondering, is there like a because I don't remember how stuff works from before. Man, I have so many things now. I have so many tools in my tool belt. What was this? Suck inge. Do I need to like do this? I don't know. Maybe that would make this a little bit easier. Okay, here we go. There's a not equal 0 any suck. I think you have that somewhere. Yeah. 0 does not equal successor. So I just need to apply or this one. Suck A does not equal 0. Okay, yeah. That helps immensely. Okay, so let's go back and rewrite with add suck. Okay, add suck. There we go. So now we have a successor of something equals 0. And now we know that that is not possible. So I can use suck any 0 here. Actually, I could probably just apply that, right? No? Okay, I don't remember exactly how this all works. Was it like uh I need to give this like A and D? No? Or is it do I have to give it like the full expression? No, it shouldn't be that way, right? Although maybe it is. Maybe I have to do like this. No. Okay, that doesn't work. Ah, I can't remember. Or maybe this is apply with. Am I going crazy? Okay, so let me reread this. Let me try to understand. So if T is this, P implies Q, a proof that and H is a proof of P, then apply T at H will change H to a proof of Q. And what do we have here? Yeah, my problem is Oh, that shouldn't be an issue though. Okay, what if let's take a step back. Let's step back. Let's step back. Because I feel like that's what I have. I have H. Actually, no, I don't. I don't have a proof of this. Of that. That's my goal. Except no, I don't. I have a proof of that though, technically, because like the not equals is that. So if I applied, uh, where the heck is it? No, it's not you. It's suck ne0. Doesn't like that though. Yeah, A does not equal to B is equivalent to A equals B implies false. Well, is false isn't A equals 0. You didn't prove that. Oh. So what you're saying is there's more. No, it just doesn't unify with the conclusion of this. So I think I do need to intro H, right? Yeah, there we go. Okay. That makes more sense. Okay, so that's what the intro H is for. And then from here, I have false. So if I cases H, do I just win? Yeah, okay, there we go. Boy. It's getting tricky. You can just mimic the previous proof to do this one, or you can figure out a way of using it. What do you mean? or figure out a way of using the previous proof to solve this one. Okay, I see. So we just unlocked add right equals 0. So this is a proof that A plus B equals 0 implies A equals 0. But this one is if A plus B equals 0, then B equals 0. Okay. I think that this is pretty easy though, right? Because then all I have to do is just reverse my A's and B's. So if I rewrite add com, I should end up with B plus A equals 0, B equals 0. Now I can just apply add right equals 0, right? There we go. Hey, I basically did that. I mean, you did that exact thing, but that's fine. That's the end of Advanced Edition World. You'll need these stamps for the next world, less than or equals world. So click on Leave World to access it. Home. Hooray! Okay. So that's that one done. We are not ready for... Oh, I guess I am technically ready for this. I think I'm going to go back, though. I think before we move on, I'm going to go to Multiplication World because I want to at least get to and defeat the final boss, like the real final boss, before we start messing around with other stuff. Okay, so how should we define 37 times x? Just like addition, we need to give definitions when x equals 0 and when x is a successor. Okay. The 0 case is easy. We define 37 times 0 to be 0. Now say we know 37 times d. What should 37 times suck d be? Well, that's D plus 1 37s. Okay, I see what they are trying to say. So it should be 37 times D plus 37. Here are the definitions in lean. Okay, so we got mol 0, A, is this type. A times 0 equals 0. We have mol suck AD. This type A times suck D equals A times D plus A. Right, that makes sense. So those are like the two proofs, or I guess two theorems that they're starting us with in multiplication world here, I'm guessing. So yeah, we're gonna get mol 0. I think that's in here, right? Yeah, mol 0 is here, and then mol suck is right next to it. In this world, we must not only prove facts about multiplication, like A times B equals B times A, we must also prove facts about how multiplication interacts with addition. Like A times B plus C equals A times B plus A times C. Let's get started. Okay. See the new star tab in your lemmas containing mol 0 and mol suck. Right now, these are the only facts we know about multiplication. Let's prove 9 more. All right, let's start with a warm-up. No induction needed for this one because we know 1 is a successor. Okay. Well, so m times 1 equals m. This is not using mol 0. No induction needed for this one. I mean, they gave me this. So I guess I need to rewrite. Like, because this is a 1. Let me just rewrite that then. Yeah, we'll use this. Okay, so now we have m times suck 0 equals m. Is that what I want? Okay, well, yeah, we have, so we should be able to apply this now. So you are going to mol suck. M times 0 plus m equals m. Okay, and now we have the power of m times 0 at our disposal. So we can do mol 0, right? Null, oops, not null. Sometimes you can tell a lot about someone based on the things that they accidentally type. Like, I was trying to create a ferret yesterday, or, well, no, actually, I think it was today. And they typoed block as blocks, BLOX. And I was just like, yep. that makes sense. Found the Roblox player. There must be like a left. No, not you. No, we're not looking for you. We're looking for add 0. Oh, what have I done? Oh dear, that's not normal. If I do that again, oh geez, yeah, no, it's cursed. It's cursed. I think we want this. Yes, 0 add. That's what I was looking for. Then we riffle. Hooray! Yeah, UI moment. Have you experienced that before, or is that an issue unique to me, or maybe I discovered something new? Our first challenge is Mulcom. So we have x, y. Okay, x times y equals y times x, and we want to prove it by induction. Ooh, okay. The zero case will need mul zero, which we have, and zero mul, which we don't. So let's start with this. Oh, all right. So, mul zero, zero mul. But you just said we don't have zero mul. So I guess I go induction on M. Something like this, right? That I think that's the syntax. Hold on. I need to stop asking these questions. I literally have a thing that tells me. Yeah, it is with. Okay, these are the further goals. Okay, yeah. That's totally a-okay. I'm just a little bit surprised I don't see like D and HD showing up here. But 0 times 0 is 0. So I should be able to just mul 0. And then riffle. Yeah, they let me do that. You're getting it right now. You're in the process of having it. It's magic. I don't know. Sometimes the universe starts falling apart. All right, so now we have 0 times suck D equals 0, and that is a little more tricky. Unless wait, can I not just like rewrite HD? Like what does that do? Or no? That's not allowed? Oh, I guess that wouldn't work. Because that's the same D, isn't it? Yeah. So I need to use mul. Was it mul suck or something? Yeah, mul suck, I think. So mul suck. Oh, I have mul 1. When did this show up? This wasn't here before. Oh, wait, no, that was what we unlocked from the last one. Oh, okay. Okay, so we have mul suck. A times suck B. Yeah, that works, I think. Okay, now I have an addition. So if I got rid of the addition, I would be good here, right? What are you plus the entire thing? I guess it doesn't really matter because if I just do an add 0, you're gone. Yeah, you're out of here. Goodbye. So now I can do the HD, and then I can riffle, and then we're good. Okay, cool. Yeah, things should be easier than what we've been doing without the training wheels, I imagine. So similarly, we have mul suck, but we're going to need suck mul. Guess what it says? Maybe you are getting the hang of Lean's naming conventions. The last level from Addition World might help you in this level. If you can't remember what it is, you can go back to the home screen by clicking the house icon and then taking a look. You won't lose any progress. Oh, challenge accepted. I'm not going to go back and look at that. Heck no. We're gonna figure this out through sheer force of will. For all natural numbers a and b, we have suck a times b equals a times b plus b. All right. So we have mul suck, but we need suck mul. I'm guessing we're going to end up using mul suck somewhere in here. But probably, well, it's I see for all natural numbers, and my immediate thought is induction. Because I'm pretty sure we just did an induction, right? Or like not that long ago. Unless there's something else that I can do right away. This mul suck looks like this, but that's like the wrong way around. We don't have mul com yet. Yeah, we have to unlock mul com. We haven't unlocked that yet. I could also cases here, I think. Right? What would happen if I did that, though? Oh, wait, that's a suck. Oh. But then mul 0 will let me do anything, right? I mean, I can improve that. Is this a good idea? This seems like a bad idea. Maybe I should actually just use induction. Oh, for the description mentioning last level of Edition World, I think that's not updated. Oh, really? The last level of that world has changed since this was written. Dang. Okay, so I guess that's not really that helpful at the end of the day anyway. Well, I wasn't going to look at it regardless. But, like, I could do this. I think this might be a bad idea. This gives me the feeling of a bad idea o'clock. Let us induction instead. Wait, why do I cases be here? Go away. Yeah. So I can still do my add 0. Oh, mul 0. Mul 0. Ruffle. Like I can still do that. Yeah. And now we have this ugly looking thing. But it looks less ugly than what I had earlier. So I'm assuming I'm on the right track. So I think I want a mul suck. Because I mean, we have mul suck for a reason. So if I rewrite with mul suck, what happens? We get this. Well, this is plus suck A, which doesn't seem that helpful. If I go back, what does that look like? Oh yeah, it's suck A times suck D. If I mul suck, I end up with suck A times D plus suck A. But no, the hypothesis or the inductive hypothesis says this. And this is kind of looking closer. Like I see these two things are close. It's just you are kind of a problem. Like if you weren't here, I think we'd be in a better place. But that's okay because I can rewrite with this. I can use this as a rewrite tool. So what if we rewrite with HD? So now we got A times D plus D plus suck A. Oh boy. Oh, you deleted the message before I could even see it this time, so that is A-okay. A times D plus suck A. How do I deal with this, though? I guess I have add suck still. Wait, what if I rewrite with add suck? Oh, then I get this. Oh, this is this does not look like it's going good places. And the last thing that we unlocked was 0 mul, but we don't have any 0 here. So this is not that helpful at all. I think I might be running myself into a dead end with this. I mean, ooh. I could return this into like a suck A times D plus A. What do I want to do that though? The thing is the like the suck D's are here. There's got to be a better way, right? Maybe the mul suck is being applied on the wrong side. Is there a way I can change that, maybe? What does mul suck look like? So mul suck looks like this. Like I'm wondering if maybe I'm just looking at it wrong. So A times suck B equals A times B plus A. So I could take something of this form and turn it into something of this form, A times suck B. Okay, let's try going back to this. Let's do this. What does that look like? Oh, it doesn't like that. But isn't that what's happening over on this side? A times suck B. We're not allowed to rewrite on that side of the fence? Or, oh no, I guess that's not... No, wait, it is, isn't it? Yeah. A times suck B plus suck... Oh, this is suck D, this is not A. I didn't realize that. Okay, so these are different. Never mind. Okay, so those are different. So that's why that doesn't work. I can do this to rewrite on the left side. I'm wondering if it'd be easier to rewrite on the right side, though. Or maybe I should be looking at like other tools in my toolbox. I mean, we have a whole bunch of these things here. Also, I'd like suck add. Let's suck eq add 0. Okay, so suck n equals n plus 1. This could be useful, I think. Maybe. So that takes suck something and turns it into whatever plus one. Oh boy. Can I do that here or should I do that here? I don't know. That feels like it's getting kind of messy. I don't know. I feel like this is the right first step though. I don't think I need to do anything more with multiplication for now. Like I see this. I definitely see this and like that's like begging me to rewrite it. I feel like they want me to do it. So I have to do it. But then what? Because I still have this. I still have you. But if I do like an oh you didn't see that. What if you just expand everything out? That's a interesting idea. I mean, I feel like that's kind of what I'm doing at this point. I guess I could work the right side as well, potentially. So if I did like rewrite, add, suck, and then give it D, does it? No? I forget how to rewrite on the right hand side, if that's even the thing. Yeah, add suck is I've just been using the heck out of this. Yeah, A plus successor of D should be that. So I feel like I want to do this on this side. Okay, yeah, I can do that. That's allowed. So why can't I do an add suck as well? I can do an add suck. Oh, okay. Ah, there we go. And now, okay, so now both sides are looking pretty darned similar. So we have an A times D plus a D plus an A. And we have an A times D plus an A plus a D. So these are not like symbolically exactly the same. But I think I can add com. That should no, not there. Can I like nth or it was like nth rewrite, then I can give it like a 1 or 2 and give it add com. I think it was like that. No. How about 3? No. Wait, why is it doing that? Oh, because that whole term. Oh, I see. No, it's got to be something else then, right? Like I can tell that like I just need to swap these two somehow, but the parentheses are not working out exactly the way I want them to. I think there is a rule for this one though, right? Add left com. Yeah, here we go. We have a rule for this. We can add, or maybe it's add right com. We have a rule. A plus B plus C equals A plus C plus B. Okay, there we go. So now if I rewrite add right com, you will add right com. And then I can just ruffle. And now we're good. Oh, Jesus. That's crazy long. It took way more effort than I thought it would. So this was just like a whole bunch of rewrites, though. I didn't have to do them on multiple lines even. But I feel like it's easier to read this way. Yeesh. Yeesh. What if you follow your title? Do you think Simp would actually just work here? Actually, that's kind of interesting. Would that have worked? I actually don't even remember how that stuff works. No. Unless I'm forgetting how Simp works. Nah, it's not doing it. I thought even at like this point it'd be simple enough for it to figure out, but no, apparently not. Okay, weird. How does Simp work? I don't know. Yeah, I thought so too. It might work for the last step. No, it apparently just doesn't. Okay, this is the first sub-boss. Oh, we got mini bosses in this game. Whoa. So the first sub-boss of multiplication world is mulcom. X times y equals y times x. Okay, so yeah, we've been working towards this. When you've proved this theorem, we will have spare proofs such as 0 mul, which is now easily deducible from mul 0. But we'll keep hold of these proofs anyway because it's convenient to have exactly the right tool for a job. Sure. Okay, and no help this time again. So they really just say, no, no more help. No more helpers. No helpers. Wait, no. Why am I just rewriting things willy-nilly when we could be doing things? Okay, so we unlocked Suckmull. And I think that's going to be useful. I think we need to do induction. I'm going to do induction on B. Why not? Okay, so first goal is a times 0 equals 0 times a. I think we can do that, right? Because we can do mul 0. Now we have 0 equals 0 times a. And we have 0 mul. So we can just ruffle. Oh, and I forgot to actually give these guys names. Okay, we're gonna give them names. There you go. Okay, so we have a times suck d equals suck d times a, and I think we unlocked suck mul, and that's going to be useful here. Right, because we have suck a times b equals a times b plus b. So how does this work? I just go rewrite suck mul. Okay, rewrite to the right-hand side. I guess that would make sense, yeah. That's the only one that actually matches. So now we have to do something from here. So I have this. I could rewrite using HD right now. No? Oh, I have to do the reverse thing. Like this. There we go. So now I have a times d plus a equals a times suck d. But I think that we can just reverse suck mul on that now, right? Or, no, because you're still suck D. Let's expand you. I feel like that might be the play. So if we do a mul suck, that gets rid of the right side. Okay, and there we go. And that's everything we need to do. And then we're done. It might work if you feed it addition, commutativity, and associativity. How do you feed it? Do you just like give it a bunch of theorems like after you write simp? Is it like simp add com? Or does simp even take arguments? I thought it didn't take arguments. Oi, 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 oi. Okay. You can prove 1 times m equals m in at least 3 ways, either by induction, or by using suck mul, or by using commutativity. Which do you think is the quickest? So we have... Okay, 1 times m equals m. And we have m times 1 equals m. Shouldn't, like, suck... Wait, didn't we just unlock mulcom? Yeah, mulcom should be the easiest, right? Mulcom in the middle. Everyone's favorite television show. Does anyone even still remember that show? Am I too old? Okay, so we have this, and then I can do mul 1. Oh, you can... Oh, you have to give it the square brackets. You recognize the reference, okay. Hey, I did it! That's my solution too. Actually, mine is better. Mine has a semicolon. I do it in 1 line. I'm just way cooler than you. John Lean. This level is more important than you think. It plays a useful role when battling a big boss later on. This is the kind of spoiler hint comment thing that Creative Ferret sends me on Discord on like a regular basis. It's like, you should go back and do crowd surfing. That level is super important. You're gonna need that for later. I'm just like, okay. Oh, you didn't grow up. Okay, with it. Okay, makes sense. See, I grew up with that show, and I don't really remember very much about it, other than like Malcolm and like I think there was like the younger brother Dewey. I think that was his name. And I think he was in the middle because he had like an older brother as well. I don't remember his older brother's name. Was it Reese or something? Okay, so we have... Okay, this is a weird looking theorem. But apparently it's very important. All right. So 2 times m equals m plus m. What do we do with these 2's? I guess we should break our 2's down into 1's. So 2 equals suck 1 is probably what we want. I feel like that's a good opening move. We get rid of that. And then we probably want to rewrite the 1. I mean, we have stuff to work with 1's, technically, but... Yeah, hold on. I have an idea. So now we apply molcom. And now we do molsuck. Okay. Now we have m times 1 plus m. And now we can do mol1. Yeah. Mol1. And then we can riffle. We're done. Oh, yours is shorter. What did you do? 2 eek suck 1. Yeah, I did that. And then you did suck mol. Oh, you don't need to use commutativity. Right, yeah, that would make a lot of sense. All right, well played. Fine. I think Malcolm middled everywhere. I like the part where he middled everywhere. Okay, our next goal is left and right distributivity, meaning a times b plus c equals a times b plus a times c. And b plus c times a equals b times a plus c times a. Rather than these slightly pompous names, the name of the proofs in lean are descriptive. Let's start with mol add ABC. The proof of a times b plus c equals a times b plus a times c. Oh, so they're just going to call it mol add instead of left distributivity and right distributivity? Interesting choice. So apparently distributivity is very pompous. Sorry, mathematicians out there. But lean thinks that you're pompous. You can do induction on any of the 3 variables. Some choices are harder to push through than others. Can you do the inductive step in 5 rewrites only? Challenge scroll? Challenge scroll in my lean game? This is not drawed. Do this in 5 rewrites only. Okay. And I have to do induction on one of 3 variables. Interesting. Do we do the challenge? So this is not the inductive step. This is just the base case. So we will base our case. I wonder what would be the easiest here. I mean, we have a bunch of like left stuff, right? Like we don't need molcom because we have like 0 mol. So I could 0 mol a bunch of stuff. If I do U, wait, why don't you repeat the rewrite? Was it just was it this? No, it was this, right? Yeah. No, it has to be because I think repeat is in here somewhere. Actually, no, I don't see repeat. But I think repeat was mentioned. Yeah, it is repeat RW. So why is it not rewriting literally everything? Because I have more things to 0 mol. Why do you not repeat? Is it because those are different? Yes. And then 0 plus 0 should be 0. So I need to add 0, And then we are good. We ruffle and you're done. You don't know why Repeat is doing that, man? It's just acting up. There's gotta be a reason for that, though. I feel like it's because it's on different variables. Okay, so now we're in Suck D land, and apparently... Why did they call it Suck D? Why did they go with D? Why D? Why Suck D? I feel like I'm asking the real questions here. Why Suck D? Why real anal? And why is there a proof assistant named Cock? What is happening? They'll be like, shh, don't question our naming choices. You're not supposed to pay close attention to what we've named things. Great, no context to join the stream. That's what happens. But for real, why do they pick such bizarre names for things? I swear, I almost feel like they're just doing this on purpose. So this is the inductive. So how the heck do I survive this part? How do I do it in under 5 rewrites or less? Well, I guess they're saying you can do it in 5, and that's like the minimum. So like, I guess I should just try and go for that. I have absolutely no clue. Do I suck mull here? I feel like this would work, right? Because it's similar to what we just did with the base case. So what does this do? That does that. So if I do suck mull like 3 times here, and then just like expand everything, I get a big clump of yuck. Okay, so I've already used 3 of my 5. Who up sucking D? Me. Yeah, Tasty Pie sucking D and and doing the real anal. Also simp. Also we have the simp tactic. Very, very powerful tactic. We love simping. Okay, so now I have like a bunch of stuff. Can I do this in 2? I don't think I can do this in 2 moves. Like we have 2 mull. So I could like reverse write 2 mull here. I think. No? Why? I have an m plus m. This plus this. Or oh no, this is the parentheses are uh-oh. Okay, but oh no, that's also not good. Shoot. Uh-oh. They did say that I can do induction on any of the 3 variables. Maybe I picked the wrong one. Maybe A was not the right choice. Not sure when this stream got 18 plus. Look, listen. I don't know how they decided the names for all these things. Okay. Don't blame me. I blame Tasty Pie for bringing up real anal to begin with. It's okay. Creative Ferret's still only on World 1. Alright, I think he just cleared World 1. But I think he said he was struggling with induction. See, I don't think I can do this in 2 moves. Like, I think I could probably do it from here. I don't think I can do it in 2 moves. Which is why I think this is, like, not the... This is not the path. This is not the way. I guess I can, like... What's the syntax? Is it like this? Can I... No, it's not that. Is it this? This is how it is in Haskell, right? What's the comment syntax again? I don't remember. Was it this? Pi, help me. Where's that Pi guy? I forget. What is the syntax for multi-line comment? /dash. Ah, there we go. That's so weird. And then //. Okay. So I can do that. Let's try induction on... Do I even want to try B? I mean, it'd be kind of methodical to try B, I guess. I feel like it's C, though. I'm going with my gut. It's C. C is the way, right? C is the way. We do an add 0. And then what do we do? Another add 0? Or no, we need a mul 0 here. Mul 0, and then we ruffle. Okay, so that one's already fewer rewrites. That just took 2. Or wait. Oh, then I have to add 0 again. Okay, never mind. That took 3. But that's still cleaner. That's fewer. That's 1 fewer rewrite than when I did induction on A, which feels maybe better. All right. Let's see. So how do I go from here, though? So my goal is A times B plus suck D. And then I have A times B plus A times suck D. So I feel like this is an add suck. So I get this. Then we have A times suck D. Is it mul suck? Okay, no, not... Oh, but this is... No, this is on the correct side. Maybe I can do another one. Okay, if I do a second mul suck, what does that do? That gives me this. See, I always end up with like a whole bunch of like crap. Which makes me feel like I can't do this in 5 moves. So maybe, okay, maybe the way to do it in 5 moves is you don't rewrite both sides. Like maybe you keep one side. You keep one side the same. Oh, I feel like I've seen, okay, not this, but something similar to this. Oh, I know that would be like the right side of this. So did I actually want to do this? Maybe not. Oh, what if I did a reverse mul suck on the right side? Did not find an occurrence of this pattern. What do you mean? It's right. It's right here, isn't it? A times B plus A. This is A times B plus A. I mean, oh, plus A, but this is plus A times suck D. Okay, no, that is different. Yeah, that makes sense that I can't do this rewrite. Because this would have to be A times suck D. Well, we still have to use our inductive hypothesis. We haven't used U yet. So if I want to do something here, I should probably move U out, then rewrite with the inductive hypothesis. So yeah, I think I do want to do mul suck here, because that gets U out, except not really. Is this a subterm, though? It is a subterm. Okay, no, that's... Okay, so that's fine. We can rewrite with the inductive hypothesis. We get A times B plus A times D plus A. Ooh, and now if I do another mul suck on the right side... Oh, okay, so we have room for one more rewrite. But this is... The parentheses are wrong. So I think I'm close. Yeah, because this is the whole term. These are where the parentheses are here. The invisible parentheses that I am imagining in my brain. And on this side, this is where the parentheses are. So I need to like... What do I need to do? I want to like move this guy out, because that's where he is here. Yeah, this guy needs to move. So there must be a rule for that. Is it... I can't remember. Was it... No, it was... Was it this? Oh, there's the UI. The UI is UIing again. It was U, right? I think. So I need to rewrite like this, because that's... Yeah, this would be my A plus C. And you would... This guy would be the B. No, wait, yeah, no, wait, hold on. No, this is my A plus B, and this is the C. Okay, no, I can definitely do that. So if we do add right com, so now we should have... Oh, geez. It's so close, but no, this side is still wrong. It's close, but not quite there. What would I need to do from here to get this right? I feel like this is an answer, but it's not the challenge answer. I can't do it in 5 moves if I do this, because I've already used up all 5 moves. Unless I did something wrong. Like maybe I didn't need to do like 2 mul sucks. Or maybe I just never needed to do the mul sucks at all. That's possible. But no, I had to do mul sucks so I could get the inductive hypothesis. Because otherwise... Because at this step, I can't rewrite using this. That's not going to work. And I can't rewrite on the right side with this because of this suck D. So like that's never going to work. At this point, the suck D is inside. Like I need to do these 2 steps to extract to this point. Then I can apply the inductive hypothesis to do this rewrite. But then I need probably at least like 3 more rewrites after that. So then I fail the challenge scroll. Okay, so what do I have to do instead? Do I need to do induction on B? Is that the answer? Because like this feels like this is as far as I can go with induction on C. Like this is the only way to rewrite it. Unless I can do something different here. Like at this stage. So I pulled that out. So this is still kind of a problem. A times D plus A. Yeah, I don't know how you're supposed to do this in 5 rewrites. I think this is a lot harder than it looks. I can probably just go for some kind of solve. So I'll go A times B plus A, and then this is plus, and then A times D. I want to move like my parentheses around though, and I don't know how. Like this matches U, but this A is attached to the wrong guy. Like I feel like I need to do something like this. So if I do what? A plus B? No, but then if I do that, then this A ends up on the outside, and then the B ends up stuck in here. Or wait, A times D plus A. Isn't that the same as where was it? No, this is add. I need to go to this. Wasn't this the same as mul suck though? It is. This is yeah, A times B plus A on this side. But then we get back a successor. Which doesn't seem very good. How long have we had that term there though? No, I literally wrote that out from here. Yeah, no, that's just reversing. That's undoing my work. But maybe I don't want to decompose this or expand it. I feel like this is getting very messy. I don't really know what to do. A times suck B. Yeah, I don't think it's a good idea to introduce more successors. Like I just don't feel like that's helpful. I just want to get rid of you. Do I have like add something? Well, that's just flipping stuff around, right? No, it isn't. This does something different. What if I do add left column? Add left column. So if I do add left column on this side, I get A times B fills A. A times D fills B. So I get A times D on the outside. And then in the parentheses, it would be A times B plus A. No, I think that is what we want. Right? No, it's applying that there. I have no idea. Wait, do I need to? Okay, maybe for this one I need to do like an nth rewrite. Well, nth rewrite. Was it 2? Add left com. That should target the one on the right here, right? Or no? Because that's what I want to do. I want to rewrite this guy, but it keeps targeting on this side, which I don't want it to do. 3? Or is this just not applying? Maybe it's not applying. Maybe I'm just not seeing this correctly. Oh god, what does it say? I don't think it did anything. No, this is still the same. A times B plus A times D. And then when we come down to here, nothing changed. Is there a reason why I can't rewrite this? Why is this not working? Because this whole thing is the same form as this. I think. It is. Why can't I apply add left com to this? Oh, this is so annoying. Like, shouldn't this work with nth rewrite? I swear this should work. This should work. It should work. Let me rewrite it. Oh, I don't need the RW. Why does that not work? Why is it not like this? Add unknown identifier, add left com. It's right here. I mean, okay, so it just doesn't like this? It doesn't like that. Oh, this is so annoying. How do I... Well, that's not helpful. No, it really does just feel like I need to do something with commutativity. Or at least something here. Can I do add left com here? Oh my god. Can we do it again? No. Oh, you have returned and moved your. I was like, what are you saying? You moved your outfit to RAX. I see. I this hurts. This hurts. How do I? Why can't I rewrite this? I don't understand. Why is this not working? Like, I'm trying to add left column on this side, and it just does not work. And I tried targeting... Wait, do I need to actually target, like... how does this work? Add left column. Yeah, add left column takes 3 arguments, A, B, and C. Like, do I need to give it A times B? And then my B is A times D, and then my C is just A? Like that? Is that gonna work? Why is it not rewriting this? Like, this is the same shape, right? A times B would fit into this A plus, and then there's a thing in parentheses over here. And then A times D it would be the B, and then A would be the C. So why is it not like this? You don't think I need commutativity right now? But shouldn't that work? Why does that not work? Why does this part not rewrite? Like, if I could rewrite that, wouldn't that just solve it? Or it may not just solve it, but like... Because then I would get my B term out. A times D would come out on the outside. And then on the inside, we'd have our A, which would be A times B. Plus A. I guess that isn't really going to help me, is it? No, you're right. That isn't very helpful. Okay, so maybe I just don't want to do this. The order of the term seems right. So is it associativity? Oh! It's this, isn't it? Oh, I'm stupid. There we go. Oh my god, I'm so stupid. It was induction on C. I knew it. Okay, yeah, and I got the challenge too. 1, 2, 3, 4, 5 rewrites on the induction step. Oh. I feel so dumb. I feel so stupid. Okay, add mul is just as fiddly to prove by induction. I like how they use the term fiddly, like we're playing an actual puzzle game, which I guess this sort of is actually a puzzle game if you really think about it. Well, there is a trick which avoids it. Can you spot it? Okay. The trick is probably you just don't use induction, if I had to guess. That's usually how it works, right? You just use the thing that you just learned to avoid doing the incredibly complicated thing. Because we have mul add. So add mul should just be mul add, but like you swap the things around. A times B plus C equals A times B plus A times C. Okay. Dude, I am not finishing this today. So I need to take U, and then I have to like distribute U. Frick induction. All my homies hate induction. Proof by induction is just, ugh, it's so painful. But I feel like it comes up so often. Like anytime it's just like, prove this thing for all integers or whatever. And it's just like, well, time to induction again. Okay, so there's a trick which avoids it. I do not see the trick. What is the trick? A times B plus C. Well, we have... Hold on. Okay, so I have the power of... I have Molcom. I have Molcom. Okay, I can Molcom. I heart induction? How come you changed so quickly? How did you go from I hate induction to I love induction? Yeah, if I'm all calm, A plus B swaps with the C, and now I can do this one, mol add, right? That should work. Okay, now I get C times A plus C times B. And now this is just more molcom. Right? Molcom that, and then molcom... No, that's... I need a target. So if I target index 1... There we go. Now I can ruffle. Here's my proof. Oh, yeah, you're so great. Yeah. Show me your really short proof. Repeat RW, molcom C specifically? Interesting. Okay, whatever. Wait, does molcom take 2 arguments or 1? It does take 2 arguments. I guess the second one just automatically... It just knows. Okay, whatever. I'm irrational. Fair enough, I guess. We now have enough to prove that multiplication is associative. The boss level of multiplication world. Good luck. Alright, no help again. No helpers. Multiplication is associative. In other words, for all natural numbers A, B, and C, we have A times B times C equals A times, and then B times C. How the... Okay. Do I need to do induction? So now we're doing associativity. Which means I don't think molcom is going to help. This doesn't look super helpful. Yeah, I don't know. This screams induction to me. All right, so we create D and HD. Okay, so this is our goal. So we have A times B times 0. And then we have A times B times 0. So how should I do this? So I just like rewrite everything with mol 0. Like this. And then do it again. And then do it again. Alright, yeah. If I just do repeat, does that work? Can I just repeat mol 0s? Or no? No, it doesn't like that. I never understand when I can use repeat. Like, why does it not like... Why does it not like repeat there? But like this looks super repetitive. And then it's just like, oh. Reflexivity. I don't understand. I feel like it has to just be like the same argument, maybe. So we have A times B times suck D, and then we have A times, and then B times suck D. So I feel like we need to do mul suck. Now what? Mul suck again on the other side? I mean, that looks okay. We have add mul. So that should help. Except... Ooh. Except I'm not sure if it will. Well, okay, but we also have this. Aha, 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 aha. I can rewrite you. Okay, so we can use the inductive hypothesis now, and we have this. All right, and now I have to go from here to here. And how am I going to do that? So we have A times B here. A times B times D is over here. So I need to distribute A. Oh, I have distributed to distributivity, right? Admol. Admol is distributivity. That would be U. I can do that there. A plus B times C equals A times C, B times C. I think that's right. Isn't it? Because it doesn't apply here, but I think it does apply over there. Or do I need mul add? Mul add looks better for this. Although I think mul add might target this instead. I guess that isn't the worst thing in the world. Oh yeah, that's totally fine. Okay, cool. We are golden. There we go. Yeah, we did it! Yes! A passing mathematician knows that you've proved that the natural numbers are a commutative semi-ring. If you want to begin your journey to the final boss, head for Power World. Yes! Finally! My passing mathematician showed up today as well. Okay, so there's Power World, we've got less than or equals world. Oh boy. We have so many more worlds left. So 3 more worlds. I think we're not going to be able to do this all today. Because I am slow. I am bad. So this is the final boss. This is like the main story ending. Fight the power. Row, row, fight the power! This world introduces exponentiation. If you want to define 37 to the power of n, then, as always, you'll need to know what 37 to the power of 0 is, and what 37 to the power of suck d is, given only 37 to the power of d. Yeah, I'm pretty sure in Idris, usually the convention was k. If I remember correctly, it's usually like suck k. You can probably guess the names of the general theorems. So you got pow 0, which would, yeah, a to the power of 0 is 1. And then pow suck, a to the power of suck b equals a to the power of b times a. Using only these can you get past the final boss level. Levels in this world were designed by Cian Carey, a UROP student at Imperial College London, funded by a Mary Lister McCammon Fellowship in the summer of 2019. 2019! That was like 7 years ago. Thanks to Cyan, and also thanks to Imperial College for funding her. Well, there you go. That is, wait, the levels in this particular world. They didn't say anything about the other worlds. So I thought maybe we had finally learned the identity of John Lean, but I'm actually not sure. Imaginatory shout out. Mathematicians sometimes debate what 0 to the power of 0 is. The answer depends, of course, on your definitions. In this game, 0 to the power of 0 equals 1. See if you can prove it. Really? Is this actually a controversial thing? I'm not a math person, so I didn't know that this is a thing that was controversial. Check out the POW tab in your list of theorems to see the new proofs which are available. POW 0. Because if that's true, that's crazy. Because I was always thought that anything to the power of 0 is 1. Alright, so yeah, a to the power of 0 equals 1. And we have 0 to the power of 0 equals 1. Well, can't we just rewrite power 0? And then ruffle? Yes, okay. Easy. Easy clappers. So usually it's a debate between whether it's a 0 or it's a 1. But we've just seen that 0 to the power of 0 equals 1, but if n is a successor, then 0 to the power of n equals 0. We prove that here. Aha. Interesting. Do I need to do induction? I hope not. I hope not. Okay, what did we unlock? We have POW suck. So that's new. M to the power of suck n equals m to the power of n times m. So I'm definitely going to need to use this. And we just solved this one. Really, 0 to the power of 0 equals 0 is also a good convention, but it is not a good convention in this game. Huh. I wonder which side of the 0 to the power of 0 war Imaginatory falls on, because he's a mathematician. I wonder what he would choose. Or maybe it just depends on what you're trying to do. Maybe that's what it is. But like, how can you have a thing be equal to two different things depending on like whatever you decide? Like, I don't know. To me, that's so weird. Like, shouldn't there just be like one definition for something? Why is math so confusing? Why can't mathematicians even agree with themselves? So we don't need you, at least not right now. I don't know if I would benefit from doing induction here. I mean, I might. This seems pretty good already, though. So if I rewrite with POW suck, what do I get? 0 to the power of m times 0. Okay, so now we can mull 0. 0 to 0 equals 0. Okay, then we're done. Okay, that's easy enough. Okay, let's at least try to beat this world today. If I can beat this world today, I think I'll be happy. What? Oh, there's just nothing. They just have nothing to tell me. Just prove it. Just do it. All right. No, no blurb at all. POW 1. I mean, I guess, yeah, that kind of makes sense. So I think what I need to do is break down 1 into a 0. So if I take 1 equals successor of 0, so we'll rewrite this, and it'll take 1 eq suck 0. What does that do? Doesn't need that. And I have a rule that matches this, which was POW suck. So POW suck can probably be applied here. I have 0 POW suck as well, but this is not 0. So I need to use POW suck here. And now I get this, a to the 0 times a. POW 0 should work here. So let's do POW 0. And they get 1 times a, and that should be just 1 mole, I think. And then we just ruffle, and we're done. Okay. Easy enough. There are no correct definitions, just useful ones. Well, I can't say I know the world of math very well, or why they or why they have decided that they are allowed to just like change the definition of stuff whenever it suits them, but if it works for them, I guess it's fine. I don't know. It's kind of weird. It's kind of like how you can just like make up imaginary numbers, though. Like, why do we have imaginary numbers? I don't know, because someone just made them up. And they happen to work really well for a lot of stuff. Okay, so we want to prove 1 to the power of m is 1. And how shall we do that? So do I need to break this one down again? Probably, right? Because I have power 1, but no, that's in the wrong position. That's not going to be helpful right now. There's no zeros. So yeah, I can't use any of my power rules, which means I need to do something different. And I feel like this is what I really want to do. I want to do this in reverse. Or not in reverse. I just want to do this. Okay, there we go. So that works for getting that out. But now what? Can I apply a power rule now? Also, yeah, this doesn't commute. So this would be nice if they actually commuted, but they don't. I mean, I just got this for some reason. Hold on, what do you say? Note that this is not quite true by definition. A to the power 1 is defined to be a to the power of 0 times a, so it's 1 times a. And to prove that this is equal to a, you needed to use induction somewhere. Induction, you say? Yeah, 0 power 0 doesn't apply. Okay, maybe I need to do induction here then. It does say for all naturals. Okay, let's start over. Let's start over. I'm gonna do induction on M. All right, so the base case looks like this. 1 to the power of 0 is 1. We have power 0 for that. Sure. All right, so that should take care of the base case. If I just do reflexivity there, and now we have 1 to the power suck d. Okay, this works with this. So now I can rewrite using pow suck. There we go. Now we're getting somewhere. We can do Mul 1. Yes. And then we can rewrite with the inductive hypothesis, and now we can do REFL, and we're done. Okay, cool. There we go. No, this lemma will be useful for the final boss. Alright. Yeah, they just basically stopped giving me hints, other than, I guess, this one. Oh, this one looks similar to, what was that other one we did? Wasn't it add 2 or something, or mul 2? 2 mul? Mul 2? 2 mul. Yeah, this looks like 2 mul. This is pow 2. So a squared equals a times a. So how do we want to prove that? I think induction on a, maybe. That seems like a good start. I like that as an opener, and then we just do like 0 pow or something. Is that what it was called? Yeah. 0. No, this one's pow 0. That's not what we want. Isn't there like a general 0 pow? Or oh wait, no, that would be this 0 pow suck, because you are a successor. Ah, but you need to be rewritten as a successor of something, don't you? Unless, okay, hold on. Let me try just doing a 0 pow suck. Does that just work? No, it doesn't. Okay, so I do need to break down the 2 into a 1. Okay, so 2 equals suck 1. Okay, that lets me do 0 pow suck. Okay, cool. And then we have 0 mul. Right? And then we can ruffle. Okay, that's the 0 case done. Now we have to do the inductive case. And this one looks painful. I guess I should do this to begin with. So same as in the base case. Now we have u. And so we can probably use... Oh, what if I work the other side of the proof first, actually? Or what if I do this? Like this goal, I can probably extract this out, right? Oh, well, no, then it gets kind of ugly, though. I mean, we might have to do that anyway, though. Okay, let me undo that. I think we do want to do pow suck here. It's kind of ugly, but... Well, if I don't do pow suck, that's just... Wait, what did that do? So it took the... Okay, then I can do what? 1 mul? Or is it mul 1? Oh no, you're to the power of 1. Oh, okay. I just noticed. Okay, you're to the power of 1. This is times suck d. Ah. The thing is, I feel like I'm getting further away from like No, that's not gonna help me. Can I do pow suck here? No, because this is multiplication, right? I mean, that's what I just did. No, this doesn't seem right. Maybe I didn't want this. You know what? Maybe I didn't want this. But then this doesn't work. Hold on. Because what if I wanted to keep the 2? Okay, whatever. Just stop. The problem is this is here though instead of there. No, I can't do anything without what I just did. Like I'm pretty sure that I have to end up in this state in order to continue the proof. Because I can't actually I can't continue to work from the 2 because there's just no way of decomposing that otherwise. Why didn't you just start by unwrapping 2 without induction? Because I'm stupid. I don't know. If I do this, oh god, I'm pressing all the wrong buttons. I pressed Copilot on accident. I'm so used to using a Mac. Okay, it's Control C, not Command C. So I use the same keyboard for my Mac. It's like a USB keyboard, and so like the Windows key becomes Command, and so I'm so used to pressing Command C, and like that just brings up Copilot on Windows. Okay, so if I did this instead, I feel like this would still be the same. Yeah. Oh, but that changed. No, that's different because that changes my induction hypothesis. Okay, that is different. Oh. And then I can do stuff with this. Okay, yeah, no, that's smarter. That makes a big difference. I did not realize that. So is this mul suck? Or is there something else I can do here? Because, like, I don't want to go into the additions. It's not really what I'm looking for. Like, I want to remove, Dude, what did it look like before this? It was that? I don't think we have, like, a way of, like, extracting suck from both sides here. Yeah, this is not POW 1. This is POW 2. So if I could remove this, I'd be fine, but I can't do that. There's no magic for that. Yeah, I think I have to do POW suck, right? Like, there's just no other way. And then I get this. So where do I go from here, though? Also, I forgot about the piano stuff. Does this matter ever? Doesn't seem like it does. Nah, I don't think so. I don't need induction? Really? Am I just shooting myself in the foot? Am I stupid? A to the power of suck 1 equals A times A. No, that can't be right. That can't be right. Because that's not... Well, I guess I could rewrite this with... POW suck, right? POW suck could be used here. We get A to the power of 1 times A. But then, wait, this is A... Oh, you're right. Okay. You're right. Wow. Well, now I feel stupid. See, I feel like I'm not getting better. I feel like I'm not getting better though. If I'm being told that I don't need to use induction. It's like watching Sisyphus, but the hill is just a speed bump. I didn't know what to do. I don't know what to do. Like, how do you know when not to use induction? So we have 4 more puzzles to go. I guess I should just like try everything that I have first and like reach for induction as like a last resort. Is that maybe the best way of attacking a problem? Because I feel like by reaching for induction first, that was how I ended up getting myself all caught up. Like I feel like when you reach for induction, it's very easy to like go on like a very long dead end path. So why not explore the things that are very short dead end paths first? I feel like maybe that's the strat. Like just avoid doing induction first until you're absolutely sure that like nothing else will work. It was a very similar situation to the 2 times m equals n plus m proof, and I didn't use induction for that one. Oh, I forgot. I forgot how I did that one. Yeah, you're right. It was actually similar to that proof. I should have just been able to do that, huh? Huh. See, I thought I probably had used induction then, but I guess I just didn't. Okay, so now we have a to the power of m plus n equals a to the power of m times a to the power of n. And we have POW 2. I don't know if POW 2 is very helpful. Okay, do I have anything here that looks like it would be helpful? Or should I actually go for the induction this time? Successor b equals a to b times a. Well, it definitely isn't u. There's no 1s or 2s. Wait, what did I do in this one? I just... Oh, yeah, we decomposed that. That's why. And then we did have a suck to work with. But this one, I don't have anything I can decompose. Okay. I think I'm starting to see something. Like, if I don't have access to suck, I can't really apply any of my rules, right? So like here, because I had an actual like literal value of 2, I was able to decompose that into something with a suck, and then I was able to latch onto that. But here I don't have a suck to work with. Which is making me think that this one I do need to use induction for. Induction wasn't even a dead end. There was an a times 1, and I kept not using power 1. Or, no, it's not an a times. It's a to the power 1. Oh. Oh. So I could have probably done it with induction. I'm just blind. Got it. Understood. So Okay, well in that case, then I'm just gonna do I'm gonna just do induction on this one. Okay, see, I see the zeros. Look, I'm there's a 0 here and there's a 0 here. I can do something with that. I can get rid of that first one with add 0, and I get rid of this one with pow 0. Yeah, look, see, and then there's like well. Oh wait, this is a term times 1. Wait, I can rewrite that too, because I can just do mul1. Oh, okay, that works. Well, this is just the base case, so like the base case is always easy. So now we have suck, and we can start doing stuff with that. So I could do like add suck here, I guess. And then I can get suck m plus d, and then we can do pow suck on the right side. Except that didn't work. Wait, what? Why did it rewrite the left? Oh, because it also applies on the left. Okay, so if I do pow suck there, we get we get this, which is in the induction hypothesis, so we can do that. Okay, well, I feel like I'm close. Now I just need to do another pow suck on the right side. And now I think I can use probably associativity. This looks similar to a problem I had before. Okay, I'm gonna do wait, how come we don't have all the multiply? Oh, right, there's an advanced multiplication world. Oh boy. Is there an advanced power world too? That's scary. That's worrying. Mul asok. Okay, I think that's it. I think I have done it. We are good. We win. Level complete. Easy. Okay. The music gets ever more dramatic as we explore the interplay between exponentiation and multiplication. If you're having trouble exchanging the right A times B because rewrite mulcom swaps the wrong multiplication, then read the documentation of RW for tips on how to fix this. Okay, so they're giving me some hints. Heck, they're even telling me to use RW mulcom at some point, so that's good to know. Wonder why they're telling me that outright here. It feels like cheating. Okay, so do I have anything that I can work with for this? I just got pow add, but nothing fits that form. So I feel like that doesn't work. There's no literals I can decompose. There's no zeros and no suck. Okay, so this is induction. This has to be induction. I'll do induction on n. Okay, so this case I can do pow 0. And then I can just do pow 0. And then I can do pow 0. And then I can do mul 1. And then I can ruffle. Okay, that's the base case done. Pow suck. Oh, need to do this. And then I do pow suck again. And then pow suck a third time. Okay. Ah, and now we have multiple A times B's. However, do I even care about that? Because I could just literally rewrite with the inductive hypothesis now. Okay. So now I have this. Now there's U over there. And then we have this times A. That's not what I want. That's okay, because we can use associativity to get the A over there, right? I think we can just do mul a sock and then mul a sock. Or no. Oh, I do need to commute. Oh, I need to commute U. Don't I? Cause wait, where's the other A? Oh, this is confusing. Okay, hold on. Maybe you are getting better. Am I getting better? Uh, God, I hate these situations where there's like a big string of text in front of me. Like whenever I see stuff like this, it just feels like in my brain it turns into like symbol soup, and then I don't know. My brain feels like it's melting. I mean, they're telling me to do a mol com, so I feel like I don't want to do this necessarily. Like, exchanging the right A times B, but there's no. Okay, so maybe they're talking about this situation, like. No, but then if I use molcom here, it does, yeah, it does make sense that it should swap with this entire thing. Maybe simple work. All it turns out you just need to reorder. Yeah, that's what I'm seeing. Okay, fine. Let's try it. Let's try simp. Simp never works. Unless I use molcom. Oh, maybe. Maybe. And mol a sock? I mean, it did something. It tried. I don't know if. Oh, I see B times B, but no, that's not attached to that. That's attached to the right. Order of operations. You will happen first. I don't know. I feel like this is just turning into spaghetti. Yeah, simp doesn't work. I don't know how simp works. I don't know how to make simp work. Simping ain't easy. Oh, no. Wait. But then there must be like a mul. There must be something I can do with like multiplication, right? Molcom would work here. I could get like B times A. No. Do I need to do nth? What does it say? There's a simp add. Oh, that's for addition. See, I think I need like a simp multiplication or something. Hmm. Old-fashioned way it is. Yeah. I'm missing something. I have a hard time dealing with like commutativity and uh associativity. But I feel like I want to get this A all the way over here. But this is in the wrong place. So you and you need to swap associativities, right? Because we don't want parentheses around here. We want parentheses around here. I think that's correct. So in order to do that, that's just moving the parentheses around. So that should be associativity, right? Yes. So I've moved my parentheses. You're here, you're here. Okay, that seems good. That seems like a good first step. Oh. Oh, no. Yeah, that's kind of right. Except you're here and you're tied to this. Oh, so what if I did associativity on the right side? Can I do that? There we go. Yeah. Now I get this and this on the outside. That looks better. So now my problem is you guys. You guys and you guys. So A times B. Okay, so B to the power of D times A times B. This should be like, was it mol com? Okay, just think about what terms next to each other you want to swap. Then get those two things surrounded by parentheses. And com, target if needed. But my B to the power of D. Oh wait, no, yeah, this is just multiplied by that, and that's multiplied by that. Oh, okay, no, yeah, that makes sense. So I need to just move the parenthesis, or no, I need to commute U with like U. Okay, let's try that. Let's commute U with U. Okay, yeah, I flipped U. So now I've targeted that side. This is looking closer to good. I just need to... Okay, so you're associated with the wrong guy. I need you to associate with each other. So if I want to do that, I need to roll a sock like this. Okay, yeah, that's looking good. That's looking excellent. Now I just need to do mol com A B. There we go. Okay, that should be a solve. Oh, I didn't do what they suggested. I did something different, but I kind of got there. Okay, yeah. So I just need to be better at like noticing like where the parentheses are, and then like targeting stuff more aggressively. I think the problem I'm having is the bed mass stuff. Like every time I look at something and it's like there's implicit parentheses and I don't see them, my mind is not like parenthesizing things correctly at a glance. Like if I think through it and I read through it, then I know where the parentheses are, especially if I'm like mousing over stuff, but I kind of have to like mouse over it first. One of the best named levels in the game, a savage Pow Pow. Pow Pow sub boss appears as the music reaches a frenzy. What else could there be to prove about powers after this? I'm sorry, I don't have an appropriate playlist for this. Because I could do the boss music. I just don't have I don't have like a good playlist for this. Perhaps I will look for one next time I am doing more of this game. I'm a little bit worried about just like pulling like Nintendo music and just like playing that on stream though, because it's just like I don't you never know when like someday you suddenly get copyright struck by John Nintendo. Like sometimes a channel will just have a bunch of stuff with Nintendo music in it for a while, and then suddenly one day it's just like, nope, not anymore. And it could be like from videos that were uploaded like years ago. So it's a little scary. It's a little too scary. So we got Molpow. The power of Molpow. And I don't think it helps me. So I don't immediately see a way, like there's no literals to decompose. There isn't so we have a to the power of m to the power of n, but this is a times b to the power of n. So like we don't have anything of this structure. This would almost be the right structure, but these don't commute. So I want to say that there isn't anything else I can do here other than induction. So I think we're gonna induction again. That's all I know how to do. All I know how to do is just induction. Okay, so now I can rewrite POW 0, and then rewrite with mul 0, and then rewrite with POW 0, and then get rid of that case, okay? And the base case is always easy to prove. Miyamoto sends the ninjas to your house. Yes, John Miyamoto himself. All right, so we can POW 0. Right? Hello? What's going on? Was this not right? Why is it... What's it doing? Did I not just... What? Was that not right? Did POW 0 not work here? Hello? This should have worked. POW 0. Yeah. What was going on there? That was weird. Okay, now it's fixed. Okay, this is POW suck. Oops. Yeah, POW suck. We can probably do mul suck, if I'm not mistaken. Mul suck looks like that. Sure. Okay, mul suck. That's looking juicy for the inductive hypothesis. Okay. And then at this point, is there anything else I can do here? So I have a to the power of m times d. We have mul pow. Okay, I could use mul pow here. I think I'd have to do it in reverse, but I think mul pow works. No? Is it? Does that not work? Am I not seeing this right? A to the power of n times b to the power of n. Oh, because these are different. Okay, I see. Right, n and n. This is m times d and this is m. So these are different. Okay, so that doesn't work. That's why. So mul pow does not apply. I am misreading this. Oh, I typoed? Oh. I have a bad habit, or I don't know. Maybe it's my keyboard. I swear I'm doing snake case, but then sometimes it comes out as kebab case. A to the power of m times d times a to the power of m. I mean, I surely have what I need to solve this at this point. There's an addition here though that I'm kind of like I'm not sure about that. Oh, but then no, if I don't apply that, then there's still a suck there. Did I do induction on the wrong variable? I guess that is possible. Yeah, I may have chosen induction on the wrong variable. Like, surely you can do something with this. This looks familiar. I've seen this form before. But wait, no, didn't I just rewrite that from something? Yeah, no, I'm pretty sure I rewrote that from something. That's why it looks like that. A to the power of what? Unless... No, that's not... That's not pow suck. Unless... Was there another way to pull the suck out of there? Or no? I don't think so, right? It's always going to be mul suck. We had mul add, actually, didn't we? I guess I could have done this. Like at this point... No, what this is... No, this is actually a different scenario. Nope. So it's not mul add. And that's the same, I think? Yeah. A to the power of m times d. Like I see the m times d there. I see the m times d there. That's good. There's an a here. It's just that the powers are wrong because this is grabbing too much. I don't want it to grab that. Yeah, this plus is annoying. What do I do about the plus? I feel like it wouldn't be this, though. There's probably something here. I don't think it has anything to do with this, right? No. Yeah, that's just for addition. There's nothing there that would help probably. Mole Pow. I mean, they gave us Mole Pow. Is that useful here? I thought I already said no, it's not. I think I already determined that it can't be. I'm going to explode. You see it? You see this? Is this also sponsored by AMD, or is there some other reason I'm using those variables? There's no reason why this has to be called D. They usually, when they taught me how to use induction, they were like D. So I was like, okay, D. I don't know. I often typo and to AMD. Because N and M are just close on the keyboard. This is gonna make my brain explode. How do I do this? I don't understand. You're in a bad place. This plus M is a problem. I need you out of here. Get out. I must be able to just like pull this out somehow. But no, but I have to get rid of the M. Do I not have didn't I literally do a thing about this somewhere? Or have I not done that one yet? Like something was like something plus something. I can't remember. Oh, here we go. POW add. Wait, how did I not see this? I am blind. It's this one. This is the one. I think. Is it? Well, yeah, no, yeah, because this whole thing is plussed. Okay, that's what I need to. That's what I was not seeing. It's this. There we go, and now everything works out. Holy cow! I just need to see the one thing. God, I'm so stupid. You were taught induction with K for some reason. I was taught induction with K as well. In Idris. Idris uses K. So I use K there, but lean for some reason they teach it with D. Yeah, our parent solves in one step. All right. The music dies down. Is that it? Of course it isn't. You can clearly see that there are two levels left. A passing mathematician says that mathematicians don't have a name for the structure you just constructed. You feel cheated. Suddenly the music starts up again. This really is the final boss. I thought that passing mathematician was gonna like make fun of me or something. Final boss music. I don't have final boss music, sorry. You're gonna have to deal with that. All we have here is smooth jazz. Add squ. For all numbers a and b, we have a plus b squared equals a squared plus b squared plus 2ab. Okay, so there is a 2. There is a 2, and that means I can do stuff with that. Well, I have POW 2. Okay, so I have POW 2, and that's probably what I want here. Okay, so before I reach for induction, let's rewrite with POW 2. Because that feels right. There's a lot of POW 2s, though. We have to do POW 2 like 3 times. So if I do POW 2 3 times, that gets rid of all those. There's still a 2 here, though. So I guess to get rid of that 2, I need to... What should I use? I have absolutely no idea. I guess I can get rid of you with this. It's probably what I want. Maybe. No, that's part of this. Yeah, no, yeah, that's part of that. So, yeah, that probably is what I would want. You guys are not in like a great form. Oh god, do I need to do induction here too? Hmm. No, I feel like I shouldn't need induction for this. Right? Like I feel like I have all the rules. Like once I've gotten rid of all the powers, it's just a matter of reconfiguring things. I shouldn't need induction. You're right. They did say that. They did say that. They did say that. I feel dumb. I feel so stupid. You're right. They did say that. Oh. Man. At least I think that my reasoning about not needing induction is right. Yeah, John Lean did say that. I feel silly. I feel dumb. I can't remember these things. Yeah, that would have been so much better than just trying to decompose that too. Okay, so now what? Now I just have like a mess of terms. I guess I just need to keep rewriting. So can I get an A? Okay. First of all, can I get an A plus B over to the left? I think I can. You're trapped. Oh, you're no, actually this is okay, so I'm imagining parentheses around this. That's never gonna happen. Like this, at least. Uh there is a plus here which encompasses everything, which is bad because we kind of want that to be multiply. So maybe I want to like unravel this somehow. How could I forget? I don't know. Listen, sometimes I just forget everything. You beat my head with enough math, my brain will just forget everything. Is there a rule for this with additions? Mul add. Hey, yeah, mul add could totally does it though? No, because this is an add. Because these are additions. So the top level is you. Then you're the next one on this side. So this no wait, this does apply. Because there's no. Wait, no. What? But wait, you apply to this. Okay, yeah, no, you can apply it on this side. Okay, because this is multiplication, and then there's a b plus c here. So I could do mul add on the left side. Okay, there we go. Now I think we're maybe getting somewhere. Because now you're the top level. Yeah, okay, that's closer. We want a plus at the top level. And I think this also is a mul add, or I guess this is add mul. So if I do an add mul, okay, I see the a times a. That's good. We like that. Is this an add mul? This is also this is an add mul too, isn't it? Because this is the multiplication and then Yeah, okay. I'm seeing things. Do I need a target? Because now you end up like that. I kind of want to do the admiral on the far right, though. Okay, no, that works. Oh, jeez. How would you prove it in, like, algebra class? John Lean disapproves. You lose 15 lean points. No! I have to collect like terms, right? Oh. I see the b times b in here. Wait, yeah, I have a b times b here. Wait, yeah, I can move you. I can... Okay, so if I swap you around and then I reassociate... Actually, I can just do add a sock. Oops. Oh, but that did it wrong. No, wait. No, yeah, no, I don't think it did it right. Hold on. Yeah, no, that's not what I want. Okay, so I need a target, I think. So if I target you and you, I think. Wait, how did I want to do this? I'm adding you with you. Hmm. Oh, I'm trying to isolate the b times b. I think. Oh, okay. Okay, I did it. I did something good. But now I'm stuck again. Why am I so bad at math? Okay, I see the a times b. That's here. Actually, no, there's an a times b here as well. So the problem is you're a b times b and you're an a times b. And the b times b is out here. Like, all the terms are there. I just need to, like, move them around, and I just suck at that. I guess this will help me get better at that, but, ugh. Fine, add a sock. Is this gonna help me? I feel like it kinda does, because it moves you in here, and then you're there. Who's B? Oh, this B is from this side. Okay, so yeah, this might be better. Now this plus is here, though. Is that okay? Because I want the plus to be, like, there. This B times B needs to get out of here. It needs to break out of its prison, I think. No, I didn't want to. I didn't want to do that. Oh, but then okay, but actually, this looks kind of good because now this is the top level on this side. Okay, so that does look kind of closer, sort of. Ugh. But these guys are all mixed up still. I want to do like association there, I think. So if I do another add a sock, will that just work? Let me do another line. No, it's not happy with that. So I think I need to target like B times A with U. Sorry, where's add a sock? Yeah, because this is I have 3 terms, A, B, and C. And they're parenthesized. Oh, they're parenthesized the other way around. Okay. So this means I need to add a sock with this. Okay, there we go. I think. Wait, no, that just undid what I just did. Didn't it? Or... oh my god, I'm... No, it wasn't the problem. One of these... The B times B is still here. You need to get out of there. How do I get you out? That's the question I need to be asking. How do I get you out of where you are? You're in a cage, but I need to get you out of your cage. So to get you out of your cage, okay, let's take it a step back. I need to move you. The B times B needs to move out of this set of parentheses. Because this is just all addition. So I feel like, yeah, no, this is this case, A plus B plus C, and then if I do this rewrite, I can turn this term into the term that I want. So I think I need to do what I did, but I need a target. Fiddly moment, yeah, it's this definitely is feeling a little. So if I do this for my A, and then B would be A times B, and then C would be B times B. And then I reverse. I feel like this should get the B. Okay, so yeah, that's looking better. I got the B times B out. So this is here now. And then I can commute these. So if I commute... oh, okay, so add com... where's add com? What's that look like? Like this? So if I add com on these two terms, it's like this is a big term. So let's do B times A plus... oh god. A times B? Was that what I was looking at? Yeah, there we go. And then I get U out. So now the B times B is here. The B times B is here. And then I have a Bab on this side, and this one's Bab. So I need to turn Bab into Abab. But I can do that because I just need to do mul com on U. Okay. So now I do mul com in the middle on BA, and there we go. We did it. Right? Yeah! Okay, I did it. It's done. Holy cow. Back when I did this, I didn't realize this editor UI existed. Oh, that's so painful. It's all over. You have proved a theorem which has tripped up school kids for generations. Some of them think A plus B squared equals A squared plus B squared. This is the freshman's dream. How many rewrites did you use? I can do it in 12. Okay, well, good for you, dude. How many did I use? I used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. You beat me by 1. But wait, this boss is stirring and mutating into a second more powerful form? Fermat's last theorem. Oh. What's this? We now have enough to state a mathematically accurate but slightly clunky version of Fermat's last theorem. Fermat's last theorem states that if x, y, z are greater than 0 and m is greater than or equals to 3, then x to the power of m plus y to the power of m does not equal z to the power of m. If you didn't do inequality world yet, then we can't talk about m greater than or equal to 3. So we have to resort to the hack of using n plus 3 for m, which guarantees it's big enough. Similarly, instead of x greater than 0, we use a plus 1. This level looks superficially like other levels we have seen, but the shortest solution known to humans would translate into many millions of lines of Lean code. The author of this game, Kevin Buzzard, is this John Lean? Is working on translating this proof, or translating the proof by Wiles and Taylor into Lean, although this task will take many years. Oh, wow. Congratulations, you finished the main quest of Natural Number Game. If you'd like to learn more about how to use Lean to prove theorems in mathematics, then take a look at Mathematics in Lean, an interactive textbook, which you can read in your browser, which explains how to work with many more mathematical concepts in Lean. So I can't beat this level, is what you're saying. Like, I'm done. I did it. Is this... Am I actually done or good? Shoot. No? Doesn't work? Probably not. Alright, I think we've done it. I think... This, why would they fake me out with this? So the phase 2 that's not actually real. Why would they do that? Does that count as a completion? It doesn't. But then I can't beat this, right? Is there no way to actually beat this? Did they really do this to me? Like, they just... So this is a level for Kevin, or whoever. Kevin Buzzard. I guess that's really lame. That's really lame. I'm not allowed to beat this. I'm just not allowed to have this one. Ever. Alright, well, I guess I did it. It feels super dumb that they would just leave it like this, though. Like, what about the people with OCD? What about the people who are completionists? We need that 100%. I need that gold check mark on my Leafs Odyssey world. What the hell? Alright, well, I guess since that is the end of that world, and there doesn't seem to actually be an actual end, they won't let me just have the green check for that or anything. Then, yeah, I guess I'm going to leave it there for today. We're going to do this world next time, and then hopefully this one, and be done with this game, I think. Because as far as I can tell, there's no way to beat this level. Unless you're, like, Kevin Buzzard, you're John Lean himself, and you're, like, actively working on that or whatever. Kind of lame that they would just leave it like that. But at least I can have the, I guess, satisfaction of knowing that I did everything that I can do for Power World. Yeah. I have to get out of here now, though. I don't have enough time to beat the game. I really thought I was going to be able to beat the game today, but yeah, I don't know. I got stuck on so much stuff. I suck at, like, commuting and, like, associativitying things around and noticing things that are obvious. Ugh. Oh well. So yeah, next week we're gonna finish off both of these worlds, hopefully. And then we'll be back to our regularly scheduled Mega Man Battle Network, I think. Yeah, should be. Yeah. Alright, goodbye. Take care.